Now we are going to show that one function is the inverse of the other function by completing the composition of f of g of x and g of f of x. And if we get x out for both, then we have proven that they are inverses of each other. So this is what we need to prove, that f of g of x equals x and g of f of x equals x. Our two functions are here. F of x is on the left side here, and g of x is on the right side. So this will show that one function is the inverse of the other and vice versa. So let's start with f of g of x. F of g of x, we always replace the inside function. G of x is x plus 7 over 4. So x plus 7 over 4. And what does f of x plus 7 over 4 means? It means replace the x with x plus 7 over 4 in the f function. So the f function is 4x minus 7. We're going to replace that x with x plus 7 over 4. So wherever there's an x, it's best to put a parenthesis, right? Because you know you're going to replace that x with something else. So here we have 4 times x plus 7 over 4. Well, our 4's cancel, leaving us with that x plus 7 right here. But notice we still have that minus 7. So those 7's would cancel, leaving us with that x we were looking for here. So we did it that way. But notice that it said and g of f of x. So if we do g of f of x, then let's replace the f function first, right? The f function is 4x minus 7. Now, we are going to replace the x in the g function with 4x minus 7. So wherever there's an x in the g function, you want to put a parenthesis, do it, right? Now we got to replace that x with 4x minus 7. So 4x minus 7 here. And notice that our negative 7 and 7 cancels, leaving us with 4x over 4. The 4's cancel, leaving us with the x we were looking for. So in conclusion, functions f and g, and we knew this already because it said show that each function is the inverse of the other. So if they're saying show, we already know that they're inverses. We just have to show proof that they are inverses. All right, next, what if I give you one function like f of x here, but I didn't give you g of x, and I said find g of x, for example? Well, there are some steps to that. So let's check that out. There is a way to determine the inverse function. It says find the inverse of a one-to-one function. So as long as you have a one-to-one function, let's find the inverse. And the steps are change the f of x to y, if that's not already there. Then step 2, interchange x and y. Step 3, solve for y. And then you're going to write this notation right here. This is just a notation for inverse function. All right, let's look at this example over here. Find the inverse of a function y equals 6x minus 12. So here's a case where You don't have f of x. You already have y. So you can skip step 1. Step 2, interchange x and y. What does interchange mean? Flip the x and y. So instead of a y, we're going to write an x. Instead of an x, we're going to write a y. So y equals 6x minus 12 becomes x equals 6y minus 12. Step 3 is to solve for y. So that's why we are going to add 12 to both sides. And we're going to get x plus 12 equals 6y. Then we need to divide by 6. The 6's will cancel, leaving us with x plus 12 over 6 equals y. But of course, we're going to change that to the inverse function for our notation for our last step. And also recognize that x plus 12 over 6 is the same as 1 6x plus 2, because when you divide both terms by 6, 12 by 6, you will get, let me put an equal sign here, x over 6 plus 12 over 6. So whatever is in the numerator, you need to divide that by whatever is in the denominator. So you can't choose what you want to divide by 6. You have to divide everything by what's in the denominator. So every term must be divided by 6. And we know that this is understood as a 1x. Therefore, we get that 1 6x, and we know that 12 over 6 is 2. So another answer, it could be written as well as this. All right, so both answers will suffice. That's why we put or here. So both answers are acceptable. All right, so let's go and complete the rest of the problems. Let's find the inverses of these functions here. So f of x equals negative 3x plus 6. First up, since that is an f of x there, we do need to change that to a y. Y equals negative 3x plus 6. The second step was to interchange the x and y. So we're not going to put y anymore. We're going to switch that to x, right? So this is step 2. And now I'm going to put negative 3x. That's going to become negative 3y. And then we are going to do what? We are going to solve for y. All right, so let's go here. Step 3, we are solving for y now. We get x minus 6 equals negative 3y. And then we need to divide by negative 3. That cancels. So I'm going to go ahead and change our y to f inverse, right? And then we can't leave that negative down here, so we have to move it up. It could be written like this, right there on the side, x minus 6 over 3. Or it could have been written negative x plus 6 over 3. Or it could have been written f inverse equals negative 1/3 x plus 2. All of those will work. All right. And of course, make sure I put this notation on there. I thought, well, I don't want to assume that you knew that it should go on there. So let me put that notation on there as well. All right, next. We have f of x equals 3 minus x over x. So that would be y equals 3 minus x over x. Then let's change that to x equals 3 minus y over y. Get rid of the fraction by doing what? Get rid of the fraction by multiplying both sides by that denominator there. Then you get xy equals 3 minus y. The y's cancel. Your next move is to get your y's together on the same side. They are a family, and get everything else on the other side. Put your terms with y's together. So that means we need to add y so that y pops up on the left side with xy, right? So that's xy plus y equals 3 now. Great. We have only the terms with y on one side by itself. How can we get this to be just one y? Because we're trying to solve for one y, right? That's when you need to know the trick of factoring. We can factor out a y. So that would be, let me erase this so it won't confuse anyone. We need to factor out y from the left side. So that would be y times what equals 3. Well, if we extract the y out of xy plus y, we get x plus 1. All right, how do you check that? You distribute this and make sure you get xy plus y. Now notice we have a single y. That's what we want. We're going to divide that by x plus 1. So our inverse function is 3 over x plus 1. All right, next we have f of x equals 4 over 2 minus x. Well, that is y equals 4 over 2 minus x, which is x equals 4 over 2 minus y. That's the second step. Then we got a fraction. Guess what we're going to do? Get rid of the fraction. How? Multiply both sides by that denominator. So that 2 minus y's cancel. We have right now x times 2 minus y equals 4. That y, let's multiply this through. All right, let's distribute 2x minus xy equals 4. So we can get rid of the 2x because this is the term here with y in it, right? So one way we can just get it by itself is maybe just get rid of the 2x, right? So how we do that? Subtract 2x from both sides. We get negative xy equals 4 minus 2x, and then we can divide by negative x, right? And then our inverse function is, again, let's move that negative up. Minus a negative 4 minus 2x over x, or it could be written again. I always use the inverse function notation, but I'm just going to go right into it. So that's negative 4 plus 2x over x. If you brought that negative to the numerator and not just the side of the fraction bar. That is good enough for me. You can even go even further and divide both terms by x if you would like. Negative 4 over x plus 2 because the x's would cancel. But I don't know. I think I like this one better. But all of these answers work. When I put or, either or works. All right, f of x equals x plus 2 over x. Let's try that. So that becomes y equals x plus 2 over x, which becomes x equals y plus 2 over y. All right, and then we need to get rid of the fraction by multiplying by what? Y. So we get, all right, let me erase this so we won't get that black part confused. All right, so that's xy equals, all right, y plus 2. Yeah, let me erase all this. I don't want, since I'm writing black right now, I don't want this stuff to confuse you. All right, so y plus 2. Yep. So now we have two terms with y in it. So that means we need to move something to the other side, right? Where do we need to move over? We need to move over the y by subtracting it. So that is over here with the other y. So now we have xy minus y equals 2. So how do we get that single y? We factor. That's the tip or trick to getting that single y. X minus 1 equals 2. And then we are going to divide by x minus 1 to get y by itself. So our inverse function is 2 over x minus 1. All right, lastly, we have f of x equals 5 minus x over 3x plus 2. So we have y equals 5 minus x over 3x plus 2, which becomes x equals 5 minus y over 3y plus 2. So what I suggest that you do right now is pause the video and attempt this one on your own. See if you have picked up enough strategies to get to the final answer. So go ahead and do that now. I'm going to proceed, but go ahead and pause the video. All right, what should you do? Your next move should multiply both sides by 3y plus 2. That'll cancel that out. Hopefully you got that step right. We have x times 3y plus 2 now equals 5 minus y. And then let's distribute this because I already see a foreshadowing of two different terms for y's in it. So let's break this up. 3xy plus 2x equals 5 minus y. Oh, there's a lot going on here. We got to get this y on this side with this y, but we need to get rid of that 2x as well. So because we don't want the 2x on the same side with the y's, so we need to subtract the 2x so it pops over there on the left side. So what do we have right now? 3xy plus y equals 5 minus 2x. Damn, we need a single y. How do we get the single y? We will factor. Hopefully pick that up by now. Factor y out. Y times 3x plus 1 equals 5 minus 2x. Then we're going to divide by 3x plus 1. 3x plus 1. So our inverse function is 5 minus 2x over 3x plus 1.